We move now to the Himalayan, and a very important source of water. And Anil Kulkarni from the Indian Institute of Science in Bangalore will inform us about the state of the Himalayan cryosphere.
Thank you, Mr. Chairman. I would like to thank the organizers for inviting me here to deliver a talk on the state of Himalayan glaciers. Many of you are clearly aware that Himalayan glaciers is a highly controversial subject, particularly after publication of last IPCC report, because the report suggests that Himalayan glaciers are likely to disappear by 2030 and perhaps maybe sooner if present climate change continues. However, this statement is taken back and there is no need to talk as more on that. But subsequently, as a reaction to this statement, Government of India's Minister of Environment and Forest had come up with another statement which suggests that the large mountain glacier would take 1,000 to 10,000 years to respond, and particularly the amount of retreat which we see into the mountains, particularly in Himalayas, are not related to the present climate change, or it has no anthropogenic origin, but it's predominantly caused due to the medieval warm period in the 11th century, or maybe older than that, is around 6,000 years ago. And this has created a lot of uncertainties in the mind of people that whether the present rate of retreat is related to the anthropogenic origin or whether it is caused because of the present change in the climate, or it has everything to do with the past climate changes. So some of these issues we try to address in this my presentation, but before that we need to understand how much is the glacial stored water into the Himalayas, particularly in the region which starts from Karakoram, the western Himalayas, central Himalayas and eastern Himalayas. And one of the earliest work which was carried out in India by me and my colleague when I was working in Indian Space Research Organization, which suggests that in Indian Himalayas, I'm talking about the Indian Himalaya only, we have approximately 23,000 square kilometer area in a glacier. Subsequently, the Geological Survey of India a couple of years back came with another estimate which suggests that it might be around 26,000 square kilometer area. However, there are some more features like permanent snowfields were added into that. And very recently, in the last year, EC mode, which is in Kathmandu, has come with another estimate, but this particular estimate is for entire mountain range starting from Karakoram towards the up to the Myanmar, and suggests that we have approximately 40,000 square kilometer area into the Himalaya. These are the now internationally reasonably accepted estimates, where in Indian Himalaya we have around 23 to 26,000 square kilometer area, and the entire mountain range we have approximately 40,000 square kilometer area. However, the next important issue related to that is how much is the glacial stored water into in the Himalayas, and this question came because fourth report of IPCC has suggested that the very high, the 12,000 gigaton of water are stored into the mountain ranges. However, when the same scaling method, it is based upon the scaling method, and when the better inventory of EC mode came, that has significantly reduced from 10,000 gigatons to the 4,000 gigatons, essentially because the level of mapping has changed. Earlier it was done on the million scale or a quarter of a million scale, and because of that many glaciers were merged together. So 5, 6, 7 glaciers is mapped as one glacier, and the scaling is based upon the aerial extent of glaciers. So you have inflated aerial extent of glaciers, and it has given very large depth of the glacier and subsequently very large the volume as well as. But subsequently, the additional work which was carried out, where people have the slope, basal shear stress, and surface velocity, and this is where by surface velocity you can estimate by using satellite images. Then by knowing slopes, which can be also observed by now there is estimates of DEM is available. By slope you can estimate, and basal stress by geology you can estimate. And this is more scientific method, and it suggests that we have only 2,000 gigatons of water stored into the Himalaya. So you can see over a period of few years, the estimate has shifted from 10,000 gigatons to merely 2,000 gigatons. So it is not really that very huge amount of water is available in the Himalayas, but you can see how scientifically things can change very significantly as the advancement of science takes place in this particular case. Another important question is how much glacial extent is being lost into the Himalaya. There is an extensive amount of work is done, and this is very recently our colleagues in Switzerland and we have come up with a science paper which suggests that how much is and the very large area in India as well as other adjacent regions are being mapped to estimate the area changes in area extent. You can see the Karakoram and almost you can say if you can from central western Himalaya, central Himalaya and eastern Himalaya, very large area, almost 24 glacialized basins or sub-basins are being monitored to estimate the change in the glacial extent. So almost half of the glacial area is now mapped to estimate the change in glacial extent. So there are many people in India who believe that the glaciers are not retreating, and this is a huge controversy in India. I would like to tell them that you can really see that, so the glaciers are indeed retreating, and this is one of the slides. You can see over a period of time, very few years, 2004 you can see, this is a Samudra Tapu glacier into the Himachal Pradesh in India, and you can see 2004, very large amount of ice you can see, and this is a small reach which is, you can see here, and subsequently within 4 years, the entire ice wall has completely vanished and the reach is exposed on the surface. And 2010, you can see it significantly started to move, ice front is started to move behind that ridge. So these are major changes into the regions are taking place, and those who think that glaciers are not retreating need to really go into their assessment or their observation. And if you look into how much glaciers are retreating, the amount of retreating is varying from region to region. If you look into the Karakoram, which is located at the western tip of the Himalaya, and the other parts of central Himalaya, western Himalaya, and Karakoram and eastern Himalaya, you can see the amount of retreat is varying, which is retreating around 1%, 0.1% per annum, to highest one which is coming to the western Himalaya, which is coming into the almost around 0.5% per annum. And on top of that, the numerous satellite techniques have been now used to monitor this glacial retreat, and it is varying from region to region. Another key question is how much is loss in glacial mass, because we know fundamentally 2-3 things, that glaciers are retreating, but the question is how much loss in mass. And this question is essentially because there are numerous investigations which has recently came out suggest that large number of glaciers are not retreating, and they are possibly not retreating because there is an excessive amount of debris cover at the terminus of the glacier, and which retards the melting. But however, it is an important question to understand is how much is loss in the glacial mass in the Hindu Kush Himalayas. And at present, the models which is based upon numerous techniques, some of them which is based upon measurements of glacial mass into the glaciological method, where you actually go into the ground and measure the mass balance by using stakes and pits, or you can do it by numerous other techniques such as accumulation area ratio method, or you can use the geodetic method by remote sensing technique. And so one thing is very clear, that the amount of Hindu Kush Himalaya, the loss in glacial mass, is almost similar to the global average. There is neither it is substantially higher than global average, nor it is substantially lower than global average. So it is very similar to the global average. And at present, it appears that we are losing almost 480 kilogram per meter square per year. And if you convert into the total loss in ice, we are almost losing almost 20 or minus 19.58 gigaton of ice per year. And it is worth remembering again is that we have approximately 2,000 to 4,000 gigatons of ice. So the earlier controversy which I say is we are not going to lose a substantial portion of glacial mass within the next few years, but definitely we are losing large amount of glacial mass as of now. So these two figures are worth remembering, is that we are approximately losing 20 gigatons of ice per year, and we have approximately 2,000 gigatons of ice stored with us. However, the story in Indian Himalaya is substantially different, because the large part of the glaciers which are located into the Karakoram mountain range, where they are located at very high altitude, the loss mass is substantially lower as compared to the many glaciers which are located in lower altitude, particularly in the Indian Himalayas. And you can see here the amount of loss is much more higher into the Himalayas, and over a period from mid-70s to until now, we have almost lost 18 meters of glaciated ice. And the amount of loss in glaciated ice, you can see from 1978, the decade which is from 70 to almost 400 kilogram per meter square per annum, and it has significantly gone up almost 900 kilogram. So it is almost double. And this increase in the loss into the glacial ice and possibly caused because of the change in the altitude of snow line. You can see here that the altitude of snow line, which is around 4,800 to 4,900 meters, has almost shifted around 5,300 meters, particularly in the lower reaches of Himalaya. And since the lower reaches of Himalaya have smaller glaciers, and most of the communities are living around that, so those are the people, mountain people, who are living into the Indian part of the Himalayas are likely to face the adversity because of the change in the glacial extent very soon. And one fundamental, another issue you can see here, why there is a sudden increase into the snow line, or which is the equilibrium line, or it is the snow line at the end of abrasion season, it is much more higher than the temperature changes into the region. And one of the possible reasons for this could be the effect of substantial portion of terminus or region which is covered by debris cover, and because of the debris cover, not enough energy is transferred from the surface towards the ice, and because of that, glaciers retard their retreat. However, we have observed completely slightly different phenomena into the eastern Himalaya, where what happens is, because of the heavy transfer of the debris, the slope starts modifying, and because of the modification of slope, sometimes the reversal of slope also takes place. Small ice ponds start forming, and with a period of time, they grow and they become more and more stable, and eventually they become a very large, they coalesce with each other, and they form a large water body, and eventually this becomes a stable lake onto the glacier. And if this takes place, if over a period of time, because of the reversal of slope and the presence of moraine onto the glacier, if these lakes are formed, and a large number of lakes are being formed into the eastern parts of the Himalayas, where suddenly glaciers will start retreating in very fast rate. So this is a new evolution of the glacial geomorphology is taking place into those regions, and this work will be now under review. So this is another important phenomenon which we have observed in Himalayas. So there are different things, different processes are taking place now, which has potential to change the rate of retreat into the future. Another important aspect of this is how much understanding the future change into the glacial extent. This is one work which we try to understand how glaciers will change into the different parts of the Himalayas, particularly Karakoram, Western Himalaya, Central Himalaya, and Eastern Himalaya. We have used the area altitude distribution of glacier and how this overall how glaciers are distributed in each altitude zone and different region. And next slide, we will show you that we have used same IP5 model ensemble mean temperature changes, as well as we have also used the mean precipitation changes also in this region, and how temperatures are going to change in different years like 2030, 2060 and 2080. So this mean ensemble temperature changes suggest that we may have in 2030s changes from 2.1 degrees Celsius to very high as 2080, you can have 5.8 degrees Celsius, particularly if you use RCP 8.5 and particularly in RCP 2.6, the temperatures may stabilize around 2.27 degrees Celsius. Essentially, we have tried to use this change in temperature and precipitation into the model, which is based upon the accumulation area ratio model. We have converted, we have used the change in temperature into the how much ELA will shift upward onto the glacier, and then weighted it for change in the precipitation, and we have estimated how much will be the loss in the glacial mass into the Himalaya. And you can see here, if you use the RCP 2.6, you can see that the suddenly the mass balance by 2030 will go up as of now, which is around very close to the 50 centimeters. It will go up to around 60 centimeters, and subsequently it will remain stable because there is no major change into the temperature is going to change, but also there is a slight increase in precipitation, which is influencing minor changes into the mass balance. So mass balance can remain stable if we use the RCP 2.6 scenario. But however, in case of RCP 8.5 scenarios, this is substantially going to change because you can see that this mass balance will continue to change from minus 70 centimeters in 2030, and it will go as high as 110 centimeters per year in 2020. When it comes to the 110 and 120 centimeters, it means that the large amount of glaciers, the equilibrium line or the snow line at the end of ablation season will be substantially higher than maximum altitude of glacier. So the substantial part of the glaciated terrain will experience terminal retreat under this scenario. So that is, so what is really, I would try to argue that fundamentally there are three major things that Himalayan glaciers are substantially reducing. In future, there are likely to be new processes which are going to overtake the amount of retreat, maybe transportation of black carbon and significantly reducing the albedo of snow into the accumulation area may also take place. In addition to that, geomorphology also is going to change, where the formation of new lakes onto the glacier may influence the glacial retreat in future, and the mass balance because of the change in the temperature and precipitation is also likely to change, depending upon which scenario you use. Particularly if you use the 2.6 scenario, that means if you are able to somehow stable the carbon dioxide emission into the atmosphere, it's quite possible that Himalayan loss in glacial mass can be stabilized. It means that we will have a substantial reduction in the glacial area, but there will be glaciers. It's not that we are completely going to, Himalaya will be devoid of the glacier. But if you use the scenario 8.5, it's quite possible by the end of century, a substantial portion of glaciers into the Himalaya will head towards the terminal retreat. So these are some of the observations, and as well as thank you very much.
Anil, for bringing us up to date with the recent findings on the Himalayan. Questions, Stefan Amster.
Yeah, thanks for a great talk. There is also some controversy in the literature about how important the glacier runoff is for agriculture in India and other surrounding areas. Can you comment on that?
There are recent controversies essentially because many times people think that predominantly runoff into the major Indian river system is coming because of the monsoon, and because of that, its influence on agriculture is not very significant. But it's really very important, essentially because now we know that even then around 20% of stream runoff is coming from the snow and glacial melt. But also, the timing is very important. If you really understand that when this part of subcontinent experienced extreme heat, at that particular time, particularly April and May and June, before arrival of monsoon, substantial part of the stream runoff is coming because of snow melt and glacial melt. So the timings are very crucial for Indian agriculture, particularly those part of Indo-Gangetic plain which is highly irrigated. So its importance is very high when it comes to the agricultural economy.
There's another question here in the front.
I would like to, it was a nice talk.
Thank you.
You had commented on a landform change. There is a change in a landscape within, but within experience, we see that the landscape change in these areas are very slow. And what you have been modeling here is that the landscape change will initiate a glacial melt in historic time. Both I'm not able to understand because what all landscape that or landforms that we see in this terrain is quite old, say 30, 40, or a newer landscape forming takes a lot of time and not in historic time phase. And what we are interpreting from this is a historic change in a glacial retreat. Whether what should be the comment on that?
What I was trying to tell you here is that from mid-70s onward, how these lakes, which is started to form onto the glaciers, which are predominantly covered by debris. And since over a period of time, those lakes become stable, they coalesce with each other and make a large glacier and causing the glacial retreat. That was the point I was trying to make. If you are landform change, if you are talking about the morenic features and how those morenic features linked with the other issues which we are raising, I was not raising that particular point in the discussion. This may be another.
Okay, final question.
Yeah, my question already has been asked. But to add it, that this time scale of this geomorphologic change, it also gives us a kind of hope that can it be monitored engineeringly, that if you have a kind of slope change and then the glaciers start or stop retreating, there can be the human interference be there and introduced some kind of a barrier and then in future stop the retreat. Can you comment on that?
Yeah, I don't think I can comment on it because first of all, reaching there and doing any work, simple measurements people are finding demanding. But yes, in future, if the technology changes and if people are able to reach and do something there, it's a different ballgame. But right now, I think we are just trying to understand what is happening there. Applying the engineering principles to modify the landscape to ensure that these retreats are influenced, probably maybe something for future.
Okay, thank you very much, Anil.